Okay, so this is going to be, ooh, let me stand in front of it so that you can't write it down yet. Okay, so this is going to be the lesson part, the classroom part for section 1.2, but part of it is still held over from the highlighting part of section 1.2 because we're going to talk about what you do with the postulates and theorems that you highlight, the stuff you did in purple. So we talked about how if you had stuff that was in yellow, it had to be on your definitions page, or you could wait until after the classwork to say whether or not it needed to be on your definitions page. And it's the same way with this, meaning the definitions in this section, because there was one definition. It was the postulates. So as long as you know what a postulate is, we're good with you not having to write it on the definitions page. However, that is not the way it works with postulates, theorems, and corollaries. I don't care if you know it by heart or not. I don't care if it doesn't make any sense or not. It needs to be on the postulates, theorems, corollaries page. So we're going to start that. Now, postulate number 1 says, a line contains at least 2 distinct points. A plane contains at least 3 non-collinear points. Space contains at least 4 non-coplanar points. That's a lot of work. That's a lot of words. Is that really what you want to have memorized? No, I don't think so. I think you need to be in the thinking of the very shortest statement I could make that would make me remember all of this. So, this is my short statement. P1, every line contains at least 2 points. And then below that, notice I didn't write 2 collinear points. Doesn't matter. I'm not going to worry about that. But below it, I'm going to write every plane contains at least 3 points. And then space is 4 points. Now, it's true that you should probably have collinear and non-coplanar in there, or non-collinear and non-coplanar. But for the purposes of what you really need, that should be enough. It's not that you're going to come back to it and have to do anything word for word. You are going to look at this page a lot. That's the hard part of geometry. You are going to look at this page a lot. That's why you want really short statements, because you don't want to be writing great big long stuff. Now, the P1 out here stands for postulate 1. I know you knew that, right? But here's the thing. It's P1 in this book, but in another book, it might be P10. Or in another book, it might be P25. Or in another book, it might be P30. Because the numbers attached to them are only so that we can find them if we need to in the book. They are not anything that you refer back to. You don't get to say, oh, it's by P1. No, it doesn't work that way. Theorems, you don't memorize theorem numbers. You don't have to memorize that P1 is that. We don't care that P1 is that. We're just making sure we've got everything written down, so we write it down here. It's kind of like writing the number 1, but it doesn't mean anything. You don't have to memorize that number 1 is A or number 2 is D. That's not what's important. It's the A and the D that are important. So this is just like numbering our information, but it is not in any way, shape, or form anything we need to have memorized or even associated with these. If you wanted to just put dots out there, that's fine. The only problem is you have to make sure that when you put dots out there, you know where to put your dots. That's all. So in order to make sure we've got everything written down and everything is accounted for, I went ahead and put the P's and the T's and the C's up there. But it doesn't mean anything. We're never going to say anything is true by T or P or C or any of that mess. Okay, big one. So you saw me do it with one of them. With the second one, it says, if 2 distinct points are given, then there is a unique line that contains them. That's the wordy one. My not so wordy one, 2 points make a line. I like the not so wordy one. Then for the next one, it says through any 2 points, there are infinitely many planes. Through any 3 points, there is at least one plane. Through any 3 non-collinear points, there is exactly one plane. So if you will look at the top of page 8, they have a pretty little picture there so that you can see what they're talking about. So it says through any 2 points, there are infinitely many planes. If you look, C and A form a line because 2 points make a line. So between C and A is a line, but it's held in plane X, in plane Y, and in plane Z, and any other kind of way that it decides to go in there. There's a plane. Infinitely many planes. It can go in any different direction that it wants to, and it can still go through C and A. That's the part that you need to worry about. So, through any 2 points, there are infinitely many possible planes that it could be in. Postulate 4. If 2 points are in a plane, then the line that contains those points lies entirely in that plane. Now, see, they're using legal definitions and stuff. Legal exact terminology. I'm not worried about the exact terminology. That's going to be in your head. You'll know. I promise you. You'll know what the exact terminology is if you ever need it. But you need the idea. So if 2 points are in a plane, then the line connecting those 2 points has to also be in that plane. It's if-then statement. And then P5 is if 2 distinct planes intersect, then their intersection is a line. That means that planes intersect in a line. Now, if you choose to say it a different way, that's fine. It doesn't matter how you write it. What matters is that you write something down. The shortest way to say it is the best way. That way you'll be able to read through it faster to find the one that you need. That way you'll be able to, it won't look like it's a bunch of work. I would suggest leaving a space in between each of these. See how I kind of spaced them out? Because you might want to go back in there later on and just add a little caveat to something, or you might want to, it makes it easier to read basically, because you're going to be reading it. You'll be reading it a lot. Because you'll be looking for, what was that thing that made this true? And you'll need a reason. And this is your list of reasons right here. This is what you go to whenever you need a reason, this page. So that took care of postulates 1 through 5. Now let's look at the next few. We're still on our postulate theorem corollary page. We're still writing the stuff down for it. The next one is theorem 1.1. Doesn't matter what color. T 1.1, just so I know I've taken care of it. If 2 distinct lines intersect, they intersect at exactly 1 point. Now I could write the whole thing up there, but that's not necessary. What's necessary is 2 lines intersect at 1 point. No more wordy than it needs to be. Please, the simpler the better. Theorem 1.2. If there is a line and a point not in the line, then there is exactly one plane that contains them. A line and non-collinear point lie in the same plane. Now, if you want to shorten that up more, you can. It's entirely up to you how short you make it. But you do have to have something written down for it. You can't say, oh, I know that. It has to have something written down. It's not like definitions. You have to have something for every single P or T or C that we get to. It has to be on this list somewhere. Otherwise, you can't. Okay. Theorem 1.3. If two distinct lines intersect, then they lie in exactly one plane. I'm going to make that intersecting lines. Crossing, now use intersecting. Okay, and that was it for this section. I have explained everything that needs to be explained for this section. I have gone over how to write your postulates and theorems for this section. And I have even gone over the homework for this section. There is no classwork. Sorry. But there is homework. And I will send an extra sheet like we used to do for classwork so that you'll be able to check your homework. But this is technically homework, and I'm going to write it on the board, and you will see it in just a few seconds. But what you need to understand is that this homework is not out of the book. It's off the board, but it's still homework. It still counts. It's still important. Okay, hold on. Okay, those are the 9 problems for this section. How many points does it take to make a line? How many points does it take to make a plane? Lines intersected a blank. Planes intersected a blank. How many planes can contain A, B? How many points are used to label a plane? How many points are used to label a line? Give all the possible names of that line and give all the give 6 possible names of that plane. The one drawn out there at the very end. Yeah, this one over here, this plane. And look, I drew this one for that one so that you can look at it and see. Woo! So, that be section 1.2, and we will see you in section 1.3.